Yes. Doctor, your microphone is closed. Your microphone is closed, doctor.
I got it. I got it. My voice is clear?
Yes.
Okay. Thank you. Thank you. Thanks a lot, Gonzalo, for giving such a long introduction, such a brief introduction. Thank you. Uh, as you mentioned, like my today's talk would be on introduction to lithium-ion batteries. So very fundamentally, I will try to uh, deliberately concentrate on what batteries are and how lithium-ion batteries are useful and how this lithium-ion battery become more uh, advantageous to the present society and how we can think about some other way of constructing batteries away from the traditional or synthetic electrolytes and how we can use some biopolymers for synthesizing the battery and for electrochemical devices. So I will start with some very basic introduction about what energy is and what is the challenges in the present scenario and what is renewable energy sources, what are the solution if we have any problem with this, and importance of electrochemical devices, in particular about renewable energy sources, working principle of any lithium-ion batteries, or I can say any electrochemical devices. What are the very key component, and when we are discussing about batteries, and I will take you toward the electrolyte part because my area of research is in electrolytes. So I will take you toward the electrolyte, which is one of the base, or you can say a backbone of the any electrochemical device. And then I will come very gradually to the importance of biopolymers as electrolyte. Why one should think about biopolymers, and then we work. Think I will discuss some work which I have been done over here because I was taught that this topic was basically for the undergraduates and master students, but not included too much things about my research area. So my idea is to give you a very fundamental concept of electrochemical devices, batteries, and the importance of polymer electrolyte. But still, I had to make my talk completed. I had taken some uh, results of my initial research, like very recent research. So this is all about the energy, what we are using right now for the development of our society, of our country, and whatever energy we are using is a conventional source of energy. So while we are discussing about conventional source of energy, we can classify them in two areas: commercial energy and non-commercial energy. When I'm talking about the commercial energy, most of them have been taken from the coal, oil, natural gases, thermal power, and all. So, but when we are coming with the non-commercial area, it would be like firewood or hydropower or nuclear power. Like that. So, the most of the time, we are taking energy from the earth. I shown like we are plugging into the earth and we are taking the energy from the earth for various conventional way of getting this energy. If I come into the classification, like how these energies have been taken out, like nuclear energies are 28%, natural gases are 7%, hydro energy are 28 to 29%, coal energy is 29%. So, significantly a large amount of energy we are taking out of the coal or petroleum, or you can say the non-conventional energy sources and all. But the problem is like we are taking this energy for a long time and we are using the extreme development now. So this all traditional sources are being exhausted very fast. We have a limitation with this. We are not having we cannot generate it very frequently. So if we compare this all areas, you find that when we coming with renewable energy, like alternate source of energy for the traditional sources on the conventional sources, you find that we have the solar energy, we have the wind energy, tidal energy, geothermal energy, biomass-based energy. We have different ways like we can generate the renewable energy part. Out of this all, you find that the solar PVs, or you can say solar energy, is something which is rising like anything from like in India in specific particular. You'll find that Indian government is thinking about to raise this demand of energy will fulfill by solar energy in particular. Like the present government is doing so much things on solar energy. They are setting down so many solar panels in India, and huge industries also coming on this area of research. So when we are coming with this two areas of energy, like the solar energy or the wind energy, then when we are using these two sources of energy for fulfilling our requirement, you can say that like 29.5% of terrestrial and 34.2% of space efficiency enabled by thick quantum wealth superlatics and all. This is one of the recent research published in 2022. But the major limitation, which what I noticed with this type of energies are these energies are not continuous. Like in night hours, you cannot have the solar radiation, so you cannot convert that energy into the battery and all, and you cannot use it for the 24 hours. The same problem come with the wind energy. Like in India, many places are there where the thrust of air, or the flow of air is not enough sufficient so that you can create energy out of the wind. So the idea is like whatever energy I can generate in hours, starting from morning 10:30 to evening 4:30 or 5 o'clock, or whenever you have a good thrust of energy, you can convert energy by the wind flow. Then the idea is we can store this energy to any electrochemical storage devices. Once you are able to store this energy, you can use it for the left time or the remaining time when we are not having the specific condition to generate energy out of solar or out of the wind. So this electrochemical devices or energy storage devices become very, very crucial when we are thinking to get energy out of renewable energy, right? So very surprising, I added this slide intentionally, like the idea of the battery was not new. If you come with the Indian mythology, there is one Agastya Sahita, which is somewhere 4000 to 2000 BC back. There, one teacher, you can say a teacher or rishi was there, whose name is Agastya. He wrote a very fundamental slok in Sanskrit, which says that Sanstapya Madapya Patra, Patram Patra Susanskritam, Chadye Chidri Ven Chadharbi, Tasta Pasubi, Dasta Lostuho Nirdhatapya, Pardachri Distatha, Sayog Jajyate Tejo Mitra Varuna Hasta. The meaning of this Sanskrit slok is place a well-cleaned copper plate in an earthen vessel, convert it first by copper sulfate and then by the moist shadows. And then after that, put a mercury amalgamate zinc sheet on the plate of the sawdust to avoid the polarization. The contact will produce energy known by twin name of Mitra Varuna. Water will be split by this current into the pranavaya, like the atom and molecule, the ions. The chain of 100 jar is said to be give a very effective force of energy. So this is the idea of the energy storage devices. The idea of the batteries are not new. It is somewhere mentioned in our literature also. But the now thing is how we can increase the efficiency out of this. Important part is efficiency and stability of our devices. So to complete this idea, how actually battery works, I'm showing a very small animation, like what the lithium-ion batteries are and what are the important components, how they actually work out, right? This is basically for those who doesn't know about the battery and they don't know how they actually work out. So this is the separator. This white part is the electrolyte, and these two sides are my electrodes. One is the anode, another is cathode. And electrolyte is something the lithium salt, the lithium ion can move from one side to another side, like from anode to cathode. When they start moving, the electron will be released, and this electron starts flowing from the external circuit. right? Once it happens, any load which has been connected with your battery start performing their function. Like in this case, the drone is start working when you put a completely charged battery with any of the load, and the ions can easily move from anode side to cathode side. And while doing this, the cathode side become lithium cobalt oxide, and gradually it is increased. When 95% of battery will start, then we need to put it on the charging process. Once we come into the charging process, the entire process gets reversed. Right. This is what we have the adapter in my laptop or in your mobile charger, and the entire mechanism that in reverse direction, ions start moving from cathode to anode. Electrons are get been stored again to the anode side, and you can say your battery has been charged. This entire process are known as hopping and dehopping process, where the charging and discharging of battery will take place. The very important thing is you should not get your battery 100% charged, or should not use your battery till the dead end. In standard, you should not use your battery above 90% of discharge, right? And even you should not charge your battery more than 95%. Maximum charging is 95%, minimum discharging of 15%. If you maintain this limit, you will find a better performance of the battery. You can use it for a long time. Right? This is a small animation to explain what's happening inside the process. But out of this animation, we come across a conclusion that any battery or any electrochemical devices consist of the three major components. One is my anode, which is the negative or reducing electrode that releases electron to external circuitry by oxidizing the process. Second is the cathode, the positive or the oxidizing electrode that acquires the electron from the external circuitry, as I mentioned, as I shown in the previous animation. The purpose of showing animation is to make things clear that how the electrons are moving from anode side, and while charging, how the electrons are coming back from cathode side to anode side. Out of this, the interesting part is the electrolyte, where the ions, the lithium ions, start moving from cathode and anode. They're wandering between the cathode and anode by the charging and discharging process. For that, we use different sort of materials. Traditionally, these are the liquids. Maybe are using the different acids or alkaline liquids or something, and different models are available in market like AA, AAA batteries. But by coming with these three different important components, then question comes into the mind, and what are the minimum required property for these three types of parts? So when I'm coming with the anode part, anode material should exhibit the following properties. Like it should be efficiently reducing aging, high Coulombic output, good conductivity in terms of electronic conductivity, should be stable, ease of fabrication, low cost metal such as zinc and lithium are being offered as an anode materials, where the lithium ions can be released and can be passed through the electrolyte from the anode to cathode. This is what we actually require. When coming back to the cathode part, it's efficient oxidizing agent, stable when it's contact with the electrolyte. But there should not be the bulk resistance between electrode and electrolyte. It's very crucial and important part when we are fabricating any electrochemical devices. It should not be a bulk resistance, because if there is a resistance between the electrode and electrolyte interface, then the performance of the battery will suffer. Like useful working voltage, ease of fabrication, low cost, and this is the ease of fabrication, low cost is always a key parameter for any device fabrication process, which is one of the very important part. Coming down to the electrolyte, which is our point of interest for the present talk. When we are coming with the electrolyte, the should have very strong ionic conductivity. Usually, in my case, when I am working with my polymer electrolytes, like the PEO based or PVA based, like some polymer starch, like biopolymers, the conductivity is somewhere close to -4 or -5. Then our intention is to increase its conductivity up to the order of -1 or sometime -2, so that we can say that the released ion from anode side can easily move between the anode and cathode, and should not offer very high resistance to the movement of ions. No electrical conductivity. I don't want any electrical conductivity when I am thinking about the electrolytes, because if your electrolytes start offering the electronic conductivity and you are having the anode at one side and cathode at other side, then there is a full chances of having a short circuit between these two electrodes, and our battery can get explode when it will be short circuit. So I don't want any electronic conductivity when I am thinking about the electrolyte. Non-reactivity with electrode materials, properties, resistance to temperature fluctuation, safeness in handling. Again, low cost is again a very important part when we are designing any device, because if I am designing anything which is very costly, then society will not accept very easily. So to make that device acceptable by society, the cost is the very important part. The aqueous solutions such as dissolved salt, acid, alkanes are often used as electrolyte. So this is what the traditional way of designing the electrochemical devices, or you can say primary or secondary batteries, where we have one electrode, like anode and cathode, and we have liquid electrolyte in between them, because liquid electrolytes offer very good conductivity. But when we are coming with the liquid electrolyte or traditional liquid electrolytes, there are many limitations, like the temperature range of operation, corrosion of electrodes, problem of hermetic sealing, growth of metal dendrites from anode to cathode to the electrolyte medium during multiple charging cycles, and this leading eventually to internal short circuit of the batteries. Maybe you all remember that BL5C, the battery was offered by the Nokia, and around 15 years back, there were so many cases been reported where the mobiles or devices have been explored when they have been charged. So now, when we are mentioning that we have a limitation with the traditional liquid electrolyte, what is the solution to this? To eliminate or to minimize the shortcoming of the liquid or aqueous electrolyte, the way out suggestion is to replace it by some suitable solid electrolytes. And here I am mentioning in particular about solid polymer electrolytes, right? So when coming with the solid polymer electrolytes, so we should have a very good idea about what is actually a polymer electrolytes. The idea of polymer electrolyte was first coined by Fenton somewhere in 1973, where polymer electrolytes are basically a polymer containing salts, acid, ionic liquids. By any mean of medium, we are trying to increase the ionic conductivity of polymers. And polymer electrolytes possess a number of intrinsic qualities like shape, versatility, film formability, flexibility, lightweight, electrolyte leakage, internal shorting, use of corrosive solvents, and production of the hermite gases and all. And in my case, so somebody asked, what is you like about the polymer electrolyte? And I say, this is when I am coming to my laboratory and I want to prepare a thin film of polymer electrolytes, it's very easy for me to prepare by this standard solution class technique. And not much equipment is required. And if you have a good polymer and different type of salts, you can try and hit, you can hit and try, and you can get the different polymer electrolytes with various ionic conductivity. You can measure very well. And the handling of the thin film which is prepared by polymers are very easy, right? So, when we start classifying this polymer electrolyte, they are based on the sources and origin, like natural and synthetic. Most of the work has been done on synthetic polymers, like for last 50 to 60 years, people are working on synthetic polymers for synthesizing the polymer electrolytes. Now, our group is recently started working on the natural polymers to make these polymer electrolytes. These are biodegradable, and these are the nature friendly also. And based on physical state and composition, we have the three different states of like gel polymer electrolytes, solid polymer electrolytes, and composite polymer electrolytes. Again, gel polymer electrolytes offering a very good ionic conductivity, but still they are also having some limitations over the solid polymer electrolytes and composite polymer electrolytes. So these are the classification on between the gel polymer electrolytes, solid polymer electrolytes, and composite polymer electrolyte based on the different feature. When coming with the gel polymer electrolyte, as I mentioned, that they are offering the very high ionic conductivity, but having very poor mechanical strength because of the nature. Coming with the solid polymer electrolytes, they are lightweight, they are solvent-free, perfectly solvent-free, low volatility, low reactivity, good operational safety, offers the moderate ionic conductivity also. By some other mean of medium, we can increase the ionic conductivity as well. The only problem with this, like as mentioned, like low ionic conductivity. But we have some way, some different methods where we can increase this ionic conductivity. So other coming with the composite, and composite has having the high thermal stability, good interface contact, and comparatively high ionic conductivity as compared to solid polymer electrolytes. Some importance, like ionic conductivity is most important parameter. As mentioned earlier in previous slides, the ionic conductivity is closely related to degree of crystallinity and viscosity of polymer electrolytes. So it's a very fundamental concept that if you're able to reduce the crystallinity, ions can move very easily through the electrolyte between the anode and the cathode. So while we are trying to enhance the conductivity, we are trying to reduce the crystallinity by adding the different plasticizers or by adding the different salts or by adding some inorganic fillers or by any mean of medium. We are trying to make the ionic conductivity high, and along with this, we try to make the mechanical stability also, right? So these are the applications we will discuss later also, but when they're coming with polymer electrolytes, they can be used as a separator between the two electrodes, must offer the good ionic conductivity as we have mentioned. Like this is the recent research which is going on your polymer electrolytes. This is very high ionic conductivity, must have good transverse number, flexible and scale up, inclusion of ionic liquids, safety, and the best ionic conductivity is offered till date with the PO in particular. It's of the order of 10 to the power minus 4 Siemens per centimeter. But when we increase the temperature, we can get up to minus 2. Also, in our case, also we get the conductivity of the order of minus 2 when we increase the temperature beyond 65 degree below the melting point of. So at the conclusion, we can say the polymer electrolytes should have these properties: good ionic conductivity. Ionic transfer number should be close to 1. If this transfer number is not close to 1, I can say that material is the mixed conductor. That is, your polymer electrolytes has the conductivity of ion and electron both. So we should try to make it close to 1 or to 0.99, so that we can say that our substance is perfectly ionic conductivity and should have good mechanical, thermal, electrical, and chemical stability and high mechanical strength. Right? So this is now I'm coming to the biopolymers. As I mentioned, like whatever we have discussed in the previous slides, all that polymers like PEO, PVA, PP, PMA, PBA, and all these all polymers are synthetic polymers. And in the present market, we are using this energy storage devices, or you can say rechargeable batteries in a huge quantity. Like if you walk around your market, you'll find that most of the devices which are portable nowadays are on battery based, like your mobile, your laptop, your watch, everything. Everything are on the based on the batteries, and most of the time have lithium ion batteries. Like nowadays people are thinking about the sodium ion batteries because of the cost effectiveness or other things of lithium ion. But still, the host material for this all batteries are either PVA, either PEO, either PMMA, either PPA. These all are synthetic polymers. And when the batteries are get aged, or when these batteries have been discarded after the complete cycle of your battery, then these batteries become the environmental hazard. Because when you're throwing it battery, this battery will not be decomposed in soil, and gradually it will this impact the fertility of the soil. It impact the water quality of the water what we use for drinking and all. So to overcome this problem, because we cannot stop the manufacturing of battery, we need that batteries to make our things portable and small and easy to carry. So what we can do is we can change this host polymer by biopolymers. Right? What is the advantage coming with this biopolymers is whenever these devices are being aged, or you can say it's been discarded for after multiple uses or after a year or two, these biopolymers can be you can say will be degraded very easily, and these biopolymer can be used as a fertilizer for the soil. Like in the past time, like in COVID, I worked on this. Even I filed a patent on that, like where we used this biopolymer-based thin films as a fertilizers. We synthesize, we check the ionic conductivity, and while we throw it into the soil after the a month of 3 to 4 months, it get been dissolved into the soil very easily. Anyway, when we're coming with bio-based polymers, they are different class. Like polymer directly extracted from the biomass, polymer chemically synthesized from biotite monomers, and polymer produced directly by microorganisms. In our case, we use the polymer directly extracted from the biomass because the microorganisms and the biodegradable malleables. I'm not from the biotechnology side or from the biology side. It's very difficult for me to synthesize the things. But yes, we purchase these starch-based polymers like potato starch or wheat starch, corn starch. Even we have used the chitosan. We use the gum agar for synthesizing our small thin film by adding different salts into that. So if someone, any student from master side or any student from the PhD side, if you want to start working on the batteries, then nowadays biopolymer is a good way where you can think about and you can start synthesizing the polymer-based electrolyte thin films by simple solution cast technique by taking these type of biopolymers by adding different salts. You can make them good anically conductive. These are some literature which I have been taken from the internet, and some composition of the biopolymer electrolytes and ionic dopant, what they have used, and the conductivity at room temperature, what they get. And if you go through this table, you find that once you are coming with biopolymers, the conductivity is very, very low, of the order of -6, somewhere -4 or -5. This shows this area is still open for all to take this challenge to reduce the value or to increase the ionic conductivity of the order of -1 or -2. So this is still the area where we can work out and we can think about this area. There's some other table which have been shown the conductivity and the charging cycle of the battery, which has been checked out in the license solar cells, like starch, rice-based starch, cellulose, chitosan. One of our research collaborator from like AK Aru from Malaya, they are working on chitosan for a long time, and they have been reported so many papers with different salt composition with chitosan, and they have blended with chitosan in starch, chitosan in cellulose, and they've reported very good values of conductivity. Anyway, so what we did in our area, in our college, in our laboratory, is we prepared biopolymer potato starch-based polymer electrolyte system. We make the electrical characterization, what film we prepared over here, and the structural characterization are in process because, as I mentioned, that biopolymer area is new to our group. We have just started on this. And we have used some other approaches to calculate the concentration and mobility. We have finalized some formulas to calculate the concentration and mobility of charge carriers into these polymer electrolytes. So if someone interested, he can note down this process where we have used to synthesize biopolymer-based electrolytes. This is by simple solution cast techniques. It's one of the very popular techniques, and even he can find it online also. What we did is we take the potato starch with 0.5 gram as a host polymer. We disperse with the very normal salt, sodium iodide, with a different weight percentage as an iron as a salt doping, and we try to cap the ratio fixed because further we added some other materials to make this ionic conductivity more favorable to us, and then we make this stirrer more than 10 to 12 hours, and then we disperse the quantum dots and poured in polypropylene modulus for casting room ambient, finally dried under vacuum to eliminate the traces of solvent. The thing which is, which should I mention over here for those who actually want to work on this, some area when we are working with biopolymers is they are highly moisture dependent. That's why we have used some vacuum dried, and some temperature system also, where to make this film stabilized, because when you're leaving it into the atmosphere, it's taking the moisture very soon. We are still working on that. We have not find any suitable solution to this, but still the conductivity what we obtain out of this system is comparatively good. These are few films which we have prepared. Now, after preparing all this film, the major characterization which we have followed, the structural characterization, as I mentioned, we are in process to find the XRD, FTIR, and POM to find the change in structural part of the host biopolymer. DSC to calculate the thermal effect on the system to find whether the system is thermally stable and to find what is the vicinity effect on temperature. And the electrical characterization is one of the very important and favorite to me. We have did the impedance spectroscopy by using the CHI 604 instrument. We calculate the conductivity and with percent, the different temperature, the dielectric constant, TIN, and the last, interestingly, we also calculated the concentration of charge carriers and mobility of charge carriers into the system. This is a formula which we normally use to find the impedance spectroscopy when we find the value of conductivity out of this formula. And this other way of Vogel thumb and Fulcher formula, we to find the conductivity and Arrhenius typification also been used. We have not used in our area. We use directly the equation as mentioned the previous week. These are some other parameters which we use, we calculate out of the impedance spectroscopy data, like dielectric constant, frequency-dependent dielectric relaxation. This will give you the information of polarization along the ends of your interface between the electrolytes and the electrode, modulus, AC conductivity, and conductivity with different weight percent of the dispersed side, what we use over here, like different weight percent of quantum dots which we have used in system. Like as I mentioned, this is the property which we have calculated. We use the skirt and gird formula, and we made the small changes in this equation. And by changing the small areas of equation, we could able to find concentration of charge carriers out of this equation. And interestingly, every parameter you can find out of the impedance spectroscopy data. And similarly, the mobility also you can calculate by this equation. So, for sake of completeness, I am showing this data. This is recent one, which we have worked on the month of July. And this is the conductivity, and along with this side, this is the concentration of charge carriers. You can see that how this starch, potato starch, corn starch, and lignin is performing in terms of different weight percent and conductivity. So someone can notice that the conductivity is not good. It's of the order of -8 and -9, but they offer the conductivity is very important. And in the very recent part, like in the few weeks back, we developed the same area by adding some more quantum dots, and our conductivity is of the order of -5 and -6, right? So this is the percolation model, which we normally use to explain why the conductivity is changing. Like if you see in this part, like cornstarch, you can see first initially conductivity increases, then it decreases, and it starts increasing again. And this changes, two peaks in conductivity, two rise in conductivity can be explained and can be understood with the help of the percolation model. You can find this data, this literature percolation model in many of my publications, where we try to explain how this percolation happens. Like in all white, let's think about like this, all white boxes are of polymer. When we start dispersing or adding some plasticizers, like these black spots, this will give you a path of ions to start moving from one side to another side. Suppose my one of the ions start moving from this side. Let me take. Suppose if the ions can move from this side, so initially doesn't have any conductivity path because of the crystallinity parameter of the polymer. But once we are adding some dispersed side, this area can give you a flexible path to move ion from the anode to cathode easily. By adding the more impurity, it will give you a perfect path to passes from this point to this point. can say my conductivity increases. But adding more quantity of these dispersite, they start behaving as a crystalline material. And then now what happens? Now the ions start moving from this white portion, not out of the black portion. And if you're adding more quantity of your dispersite, then dispersite itself start performing as a crystallites, and it will start blocking the flow of electrons. That's why we are getting the higher and lower peaks of conductivity in the same sample and with the same concentration, right? So finally, what I conclude is like we prepared the biopolymer-based polymer electrolytes, and these polymer electrolytes offering the good level of conductivity, and this can be used as a sandwich between the two electrodes, and we can synthesize the batteries out of this. We have, like in our case, we use different samples, different thickness areas and conductivity. As I mentioned, like the highest conductivity is after -7. In the recent past, it is close to -5 and -6. This shows that still biopolymer has a good space to work over and to think on how we can increase the ionic conductivity, right? So this is all about from my side. Thank you for giving the opportunity to interact with the students from masters and PhDs. And I think it will be fruitful for those who are working on batteries, or those thinking about to start on the battery part, right? So this is all about my presentation. If